So, all right, the first thing we do is we look at this table here on the right-hand side. What we want to understand is, well, where's all the carbon? Okay? In the different reservoirs of the Earth's surface. So what we look at, how much carbon is in the ocean or in freshwater systems, and compare it, how much is of the carbon is in the Earth's crust, carbonate sediments, fossil fuels, in the atmosphere, and all living biological material, and so on. And that table now gives you the comparison. Okay? And the unit used here is called petagrams. And 1 peta is 10 to the power of 15, noting that there is a tiny mistake here in the table title. It says 1 to the power of 15, which does not make sense. Because you know with your advanced mathematics skills that 1 to the power of anything gives you 1. Okay, so this must be 10 to the power of 15, not 1 to the power. Anyway, so let's have a look at it. If you look at that, indeed, most of the carbon is stored in carbonate sediments and the earth crust. Okay, but you can see that the ocean plays a big role in terms of what's dissolved in the ocean, and the freshwater system is the second largest number. Okay, and then you can look at how much is actually in fossil fuels. Okay, how much carbon is contained in it, and it's a limited amount of carbon contained in that, but it's still a large number here. And then below that comes how much do you actually have in the atmosphere. And interesting to me is that in the atmosphere you have approximately the same amount that you have in all living biological material. You have 800 petagram in living biological material and 800 in the... Wow, that's interesting, isn't it? Okay, all right. The ocean has a large amount of carbon is stored in the oceans. So the oceans is always, the important question: what's the role of the oceans in the global carbon cycle? Is it a sink or is it a source? And when I studied in the 80s, some years back, this was not known. That was the starting point for studying CO2 fluxes, air-sea gas exchanges, and stuff like that. Now we know, but when I studied, this was not known. Okay, so now let's move over to that figure 1 here on the left. And this is all taken from your reading material. Okay, what's shown on the left is a time series. This is the longest available time series of direct measurements of CO2 concentrations and parts per million in the atmosphere. Okay, this is from one of the Hawaiian islands, from Mauna Loa. Okay, from 1957 to about 2012, and you can find updated versions on the internet. Okay, the red curve is the CO2 signal that you observe, and what's also shown is the blue curve, which is just a smooth version. Okay, they use something called a window average, run it over the curve to show the key feature, and the key feature of this curve is a positive trend, an increase from a value of 315 parts per million to until the end of this time series to about 390. Okay, and now we are already past 400. So this is the evidence of CO2 increases in the atmosphere, or one piece of evidence. Okay, this is known as the Keeling curve. Well, we know that the positive trend comes from human emissions of CO2. Okay, but what are these little wiggles? The red, sometimes it's a little bit above the blue curve, or sometimes it's a little bit below. Okay, these little wiggles, oscillations, are actually seasonal variations. And that's to do with the production and consumption or uptake of CO2. Okay, through photosynthesis and changes in photosynthesis between the seasons. Okay, so that's all fascinating stuff. Here we go. So this is the source of CO2 changes in the atmosphere. All right.